In this video, I'm going over the lesson 1.3, which is introducing the concept of z-scores and calculating a z-score. Now, a z-score is just a way to standardize the curve. And in this case, usually you'll have a mean of 0 and standard deviation of 1. So the z-score, just remember, the z-score represents the number of standard deviations above and below. So like if you recall, right, with our curve, we had our mean, and then we always had 1, 2, 3 standard deviations above, and 1, 2, 3 standard deviations below. The z-score represents how many standard deviations above and below. So like, for example, if I get something, a value that ends up with a z-score of 1.5, that means that that is 1.5 standard deviations above the mean. So 1, 2, 1.5. So this represents 1.5 standard deviations above. So that's what the z-score represents. And it's just standardizing when you're dealing with, if you need to ever compare different values. So the formula to calculating the z-score is actually on your formula sheet, so you don't need to memorize it. But for reference, for today's lesson, we'll record it. So it's x minus mu divided by sigma. Now, we already know what mu is. Mu is mean. And then what is sigma? Standard deviation. However, what is the x? So if you want to kind of make a note of it, x is going to represent the value that we're going to convert to the z-score. So x is the value that we convert to the z-score. And again, just that reminder that a z-score with a positive value is above the mean, like that example I showed you of 1.5. It's 1.5 standard deviations above the mean. Negative z-score means it's below the mean. And a z-score of 0 means it is actually equal to, it is at the mean, because it's not above or below. It's right there at the mean. Like for this first example, we are given that the average speed of vehicles on the highway is 56 miles per hour. So that's your mu, with a standard deviation of 4. So that's your sigma. We are going to look for the z-score and interpret the z-score in context. So this is my x, because I'm converting 62 miles per hour to a z-score. So again, just that reminder, and I'll write it again here. The formula is x minus mean divided by standard deviation. So in this case, what is our x? 62. 62 minus the mean, which is 56. And we always divide by standard deviation, which in this case is 4. Then you just put in that calculator and solve, and you have a z-score of 1.5, which means that this speed is 1.5 standard deviations above the mean, or above the average speed. So then 47. 47 is my x. So again, 47 minus the mean, which is 56. Divide by, again, the standard deviation, which is 4. Then put that in the calculator, and you get a z-score of negative 2.25. Now notice, that makes sense that you get a z-score of negative, because 47 miles per hour is less than the average of 56. It's slower. So this is 2.25 standard deviations, 2.25 standard deviations below the mean. You're going slower than the average. Now 56. Well, 56 is the average, so what is the z-score? 0, because it is the mean, the average. So now go ahead and pause the video and try these two for the U-try on your own. And here we go. So you should have set the first one up as 30 minus 36 divided by standard deviation of 3, which gives you a z-score of negative 2, which means that this is 2 standard deviations below the mean. And here, You have 40 minus 36 divided by 3, giving you a z-score of 1.33 or 1.3 repeating, which means again that this is 1.3 standard deviations above the average. Now going the other direction, we're still using that same mean of 56 miles per hour and standard deviation of 4 miles per hour, but now you're given the z-score and we're going to find the speed. So again, z-score is equal to the x, what we're trying to convert, minus the mean divided by standard deviation. However, we don't know what x is, right? This is what we are looking for. But now we do know what the z-score is. The z-score in this case is 1.96. So I've got x minus the mean of 56 divided by the standard deviation of 4, which is equal to the z-score, which is 1.96. And now notice we're solving for x. You're solving an equation and working backwards. So if I'm dividing by 4, we need to first get rid of that fraction and multiply both sides of the equation by 4. X minus 56 is now equal to 7.84. So now what do I need to do last to solve for x? Add 56, inverse operation. And x is equal to 63.84 miles per hour, which matches because this speed is greater than the mean, and this is almost 2 standard deviations above. So same thing again, we're looking for and converting. So x minus 56 divided by 4, but now equal to the z-score of negative 2.5. So again, we got to get rid of our fraction. If we're dividing by 4, multiply by 4. So now I've got x minus 56 is now equal to negative 10. Then last, what do we need to do? Add 56 to both sides, which gives you a speed of 46 miles per hour, which again matches that this speed is under 56 because you had a negative z-score. Then remember, if you have a z-score of 0, that is equal to the mean. So this represents 56 miles per hour. So now go ahead and pause the video and try the U-try here on your own, converting these z-scores to what the number of years actually what it represents. And here we go. So again, I've got x minus the mean of 6.3 divided by standard deviation of 2.3 is equal to the z-score of negative 1.2. Now we go through and solve. So if you were dividing by 2.3, get rid of the fraction and multiply by 2.3. Now I've got x minus 6.3, which is equal to negative 2.76. Then what were you supposed to do last to solve for x? Add the 6.3. So here you get x is equal to 3.54 years is what that z-score represents. So then B here, 2.8. Well, here I've got x minus my mean, 6.3 divided by 2.3 is equal to the z-score, 2.8. Then again, get rid of the fraction. Multiply by 2.3. And x minus 6.3 is now equal to 6.44. Then last, what are you supposed to do? Add 6.3 to get you x, that value equal to 12.74 years. So now go ahead and pause the video, try the practice problems, and then let's see how you do. And here we go. So for this first problem, you had to figure out the z-score, converting the z-score. The mean, mu, 72.4%. Standard deviation, sigma, is 6.2%. What is the z-score given that the test score was 82? So that is your x. You're converting that test score of 82 to the z-score. So you just had to set this up, 82 minus 72.4, but divided by the standard deviation of 6.2. Then here you should have gotten C. Then question number 2, you have the average for the brightness of the light bulb and then your standard deviation. Again, what is the z-score given this amount of lumens? So that is your x, because that's what you're converting to a z-score. So again, you should have set it up minus the mean divided by the standard deviation. And you should have gotten a z-score, which was A. Now, question number 3. You are given the results, but notice how they all have a different mean and standard deviation. So whenever that is the case and you're trying to make a comparison about the weakest category, you can't just go to the lowest score because they have different means and averages and standard deviation. So this is when you have to find the z-score. So for leadership, this is my x values, right? Because that's the score that we need to convert. So 22 minus 18 divided by standard deviation of 4.8. So for the info processing, 12 minus the mean, which was 9, divided by the standard deviation. So then the data analysis, 34 minus the average of 32 divided by the standard deviation of 1.8. So now the z-score for leadership is 0.83. For info processing, 2.5. For the data analysis, 1.11. So notice what is the actual weakest category? Leadership, because that had the lowest z-score. Now question number 4. This here, the setup with our mean and standard deviation, but it's asking for 95% of the data falls between what two values. So again, here's your empirical rule. 95%, which is 2 standard deviation. So again, here I've got my mean of 4,300 acres and standard deviation of 750. So 1 above is 5,050 and 2 standard deviations above is 5,800. So then 1 standard deviation below is 3,550 and 2 standard deviations below is 2,800. So 2 and 2, that's why the answer is B. Then question number 5. Here again, you're looking for the percent of scores between 70 and 80, given the average score of 72 with a standard deviation of 7. So again, I've got here average of 72, so then 79, 86, but I'm going to stop because I already noticed that even 80 is not on the curve. It's somewhere here we would have to estimate. So that means this is where we have to use the calculator and identify what's the lower bound and the upper bound, which is given to us. The lower bound is 70 with the upper bound of 80. So that means, let's see if you remember, going to the calculator and then the standard deviation of 72 and our mean 72, standard deviation of 7. So getting the calculator, you had to press second vars, then go to option 2, CDF. So then here the lower bound, the upper bound, the mean, and standard deviation. And that's why the answer is A. Then question number 6. You have the average height of the giraffe, so mu is 120 feet with a standard deviation, so sigma is 12 feet. What is the height given the z-score? So we don't know what x is, but we know the z-score is negative 1.25. Now, I also noticed that my z-score being negative, which means that this is going to be below the average of 120. So I'm going to go ahead and mark off A and B because they're above, which represent a positive z-score. So now I'm already down to B or C. So here again, we're looking for x. So x minus your mean divided by standard deviation. Well, How do we set this up? That is equal to the z-score, which is negative 1.25. Then you go through and solve. What do we have to do first? Get rid of the fraction. If you're dividing by 12, then multiply by 12. So now here you've got x minus 120 is equal to negative 15. So now what is the last step here to solving for x? Add 120. So that's why the answer here is B.